Alright, so going over the Chapter 1 practice test. The first question asks, the giant kelp seaweed is found in the Pacific Ocean. One plant grows 3 feet in the first day. If it continues to grow at the same rate, how much will it have grown at the end of 4 days? So we know that it takes 1 day to grow 3 feet, so we would simply take that 3 and multiply it by 4, since it goes 3 feet in 1 day. In 4 days, it's going to grow 4 times that, or 12 feet. So that's your answer to number 1. Number 2, we're looking at 12 divided by 4 plus 8. We remember our order of operations. We want to use, please excuse my dear Aunt Sally, recall that multiplication and division are on the same level. Addition and subtraction are on the same level. So first we find a no parentheses, no exponents, but we do find a division. So we're going to take that. 12 divided by 4 is 3 plus 8, and then we're going to add those to get 11 for our final answer. For number 3, same idea, only now we have parentheses. We've got 14 minus 8, parentheses, divided by 3. So this is going to be 6. I've done everything in parentheses. Now I can divide, and I'm going to get 2. So now for number 4, we've got 10. Notice there's no sign there, but we have 17 minus 4 in parentheses. Just like with variables, if there's no sign, I can assume multiplication. So I'm going to take 10 times 17 minus 4, which is 13. That's going to equal 130 for my final answer. For number 5, it's going to be 2, parentheses 3 times 4, close parentheses, minus 8 times 2. We're going to do what's in the parentheses first. So 3 times 4 is 12, minus 8 times 2. Now let's multiply. I can multiply these both in one step, 24 and 16. And now let's subtract those, and I'm going to get 8. For number 6, we want to write a numerical expression for 9 increased by 17. So we have 9. Remember, increasing is adding, so 9 plus 17 would go there. For number 7, 8 multiplied by 9, simply 8 times 9. You can write a dot, or you can write it out this way. For number 8, we've got 12 minus m, and we're evaluating this expression if n is 7, m is 9, and p is 2. So 12 minus m, so 12 minus 9 is going to give me 3. For number 9, m plus 3n, so 9 plus 3 times 7. Do our order of operations. Multiplication comes first. Add the 9, we get 30. For number 10, we have mn over 3. So we've got 9 times 7 over 3. We get 63 thirds. 63 divided by 3, just double check that, is going to be 21. I should have been able to do that one in my head. So now, number 11, we've got p plus 7 minus n. So that means we have 2 plus 7 minus 7. Let's add first. We get 9 minus 7, and then that's going to give me 2. Remember, our commutative property, or actually more like our associative property, says we can associate these two first. We'd get 0 if we add 2. Notice we still get the same answer too, so keep that in mind. So now for number 12, we're translating into a an algebraic expression. So 4 more than y would be y plus 4. I could also write that 4 plus y. I'm basically adding 4 to the variable y. For 13, the quotient of x and 9. Remember, quotient means divide. So I can write that x over 9 or x divided by 9. For 14, we're naming properties. We've got parentheses 2 plus 7 plus 3 is the same as 3 plus parentheses 2 plus 7. Now, you might be tempted to say associative here, but notice that I am moving you can kind of consider this something I'm adding, and then this something I'm adding, the two add-ins there. When I switch the order of those two, like I have over here, that's going to be the commutative property, anytime I'm rearranging numbers or values. For 15, I'm not changing the order. I have 4 times 3 times 6, 3 times 6 in parentheses, is the same as 4 times 3 times 6 with the 4 and 3 in parentheses. I'm going to call this the associative because I'm not changing the order. I'm simply associating different values together. For number 16, I'm going to erase this. For number 16, we've got b plus 3 plus 2. I want to simplify this, and remember, because of the associative property, I can instead group the 3 and the 2 first, and I can get b plus 5. So then for 17, I've got 3 times 4 times x, same idea. I can group the 3 and the 4 together instead, and I get 12 times x. Remember, if there's a number and a variable, we don't need the dot. We can just write 12x. For 18, 2 plus y plus 7. Now we want to think of the commutative property. I can add these out of order. I can add this 2 to the 7. I'm going to get 9 plus y. For number 19, 12k parentheses 3, same idea. I can multiply the 12 and the 3, and I'm going to get 36 times k, or 36k. For number 20, I want to find the solution. If 18 minus h equals 15, my options are 3, 4, or 5. Well, 18 minus 3 will give me 15. So that's once I try that, I know that that's the correct answer. Number 21, 9 equals 36 over m. We have 4, 6, or 8. Well, as soon as I put 4 in for m, I know that that equals 9. 36 divided by 4 is 9. So 4 is my answer. For 22, they say 12 equals 6x minus 18. X can be 4, 5, or 6. If I try 4, I get 6 times 4, which is 24, minus 18. That gives me 6. If I try 5, I get 30 minus 18. That gives me 12. So 5 is going to be my answer for that one. For 23, we have 62 equals 86 minus 2n. My choices are 12, 15, and 17. 86 minus 2 times 12 is 86 minus 24. That gives me 62. So again, 12 ends up being my correct choice for number 23. All right, on the back of that 24, a number minus 9 is 21. We want to define a variable, then write an equation to solve. So a number, any number n, minus 9 is 21. So that is, remember, means equals to. So now I want to figure out what number minus 9 equals 21. we can go backwards. We can add 9 to that and figure out that it's 30 minus 9, which gives us 21. For 25, 6 times a number, so 6n equals 48, or is 48. So 6 times what gives me 48? Well, think back to your multiplication tables. 6 times 8 is going to give me 48, because 6 times 7 is 42, too small. You could have figured out that it was 8. For number 26, we want to try to figure out w minus 6 equals 10. What is w? Well, what minus 6 gives me 10? It's going to be 16. Anything else will not give me 10. For 27, 16 equals 4x. I want to know 4 times what number gives me 16? Well, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. So we can say x equals 4. I should be writing that out for all of these. But those are my answers for 24 through 27. And we'll just do 28 over here. It's dealing with that coordinate plane on your picture. 28, name the point for the ordered pair 5, 8. So you go over 5, remember to do that first, and then up 8. That's going to be point R. For 29, the coordinate for n, you have to go over 4 and up 7 to get to n. So we're going to write parentheses 4, comma 7 for our ordered pair. And then 30, you actually have to graph this one, so let me kind of sketch a graph here. And we want 3, 7, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We'll put that here. We want 8, 9, 5, 6, 7, 8. And then we got to go up 2 more to get 9. We want 5, 1, so over 5, up 1. And we want 6, 4, over 6, up 1, 2, 3, 4. And there's my graph. My domain is the set of all the x values. Don't repeat any. So we have 3, 5, 6, and 8 going from left to right. My range going from the bottom upward is going to be 1, 4, 7, 9. So that's how we deal with number 30. And then we finally have 31 and 32. 31, we want to talk about whether this is a positive relationship, a negative relationship, or no relationship. If we talk about outside temperature and firewood sales, I would expect the greater the outside temperature, so the closer to summer we're getting, I would expect firewood sales to go down. So I'm going to say that those two have a negative relationship, something like this. For 32, month and number of children born, I wouldn't necessarily picture that having any sort of relationship. I would say maybe some months are more common than others, but it's not as if there's a sharp increase or a sharp decrease based on month of the year. So I'm going to say no relationship for number 32. For 33, the last one, the table shows the winning times for the women's 1500 meter race in 8 Olympics. Make a scatter plot with the year and time. Does it show a positive, negative, or no relationship? So for this one, I'm just going to start you out since there's only a limited amount of time left. You'll have they give you a scale there. So for instance, for 1972, the time was 241 seconds. You just simply go over to about somewhere between 1968 and 1976 and go up 241, so somewhere between 236 and 240. Plot your point. you should find that those numbers don't necessarily correlate.